Just to put the Teridion solution really into the bigger picture, a couple minutes on where we see the industry going and how this fits into some larger trends involving cloud services deployments, infrastructure as a service, and overall business models. And then a couple additional points on the global cloud network. Most of you are probably familiar with Uber, Airbnb, Instacart, other companies that are out there, duodeca unicorns, as sometimes they're called. And what we see is the world moving to a consumption model, to a SaaS model. Some people call that the gig economy as well. But nevertheless, it's a way of looking at providing services more from the OpEx direction, OpEx consumption, versus the traditional networking, in this case, CapEx model. At the same time, we see networking following compute. You're familiar, the world before virtual machines and containers, where you had applications over an OS and very much hardware dependency, a monolithic application, a monolithic operating system, on-premise, and all of you are familiar with the pets and cattle analogy? Raise your hand if you're not. No? Okay.
No.
Okay. Pets, the old style way of spinning up resources for compute. Cattle, spin them up quick. If something happens, you shoot them and you go on to the next cattle. So nevertheless, when we saw this transition in compute, we removed the traditional OS. We created an abstraction layer, combining the OS, combining a hypervisor, now containers, and we ended up with a virtualized environment. We ended up with something that supported the cloud, and we ended up with the cattle analogy. Well, we're doing the same thing with networking, where traditionally you had, say, routing as the application, running on the OS, running on the hardware, and we've created this abstraction. But now, instead of the abstraction running on a single Intel CPU, the abstraction is running across every cloud service provider. Think of it as a distributed cloud hypervisor or operating system that allows us to programmatically bring up all these resources on demand, as Elad described, tear them down on demand, and scale linearly with any cloud operator that's out there. So this really supports our vision, where I talked about the consumption model, and our view is that networking needs to move from the monolithic model to something that was based only on hardware to something that is more virtualized and more distributed. And this took really a great deal of intellectual property to really scale networking within the cloud service providers. And we can do that. We abstract and we virtualize. And if you want to draw a parallel in history, VMware, if you look at the last slide, really perfected this for the compute environment. We're going to be doing this for the networking environment. And beyond a single customer, beyond a single cloud service provider, beyond a single protocol or application, we can have that much of an impact in the industry as VMware had in their respective space in compute. I'll skip through this because this is what Elad covered in great detail, but this will help put where we sit in perspective and also answer some of the questions about CDNs and about SD-WAN and SD-LAN. If I go back to this, we created this cloud overlay, this cloud abstraction. And you've got current approaches that don't require this. If you look at CDNs, it's public end user, it's one to many, but it's really optimized for web traffic. Didn't need a cloud overlay. If you look at SD-WAN, it's really optimized for any type of traffic, but it's really a closed community. Branches to enterprise headquarters to some cloud service providers or cloud applications. And for those following Gartner, it was kind of interesting. Their technology lifecycle just came out in the last week, and they placed SD-WAN at the hype of inflated expectations. That happens with technologies lots of times, and then it's going to slide down the slope. Eventually, some parts of it will come out on the leading edge, maybe 5-10 years from now. But what we needed to do was create really an entirely new approach that was for the public end user, that was optimized for all IP, and we realized that new approach through the cloud overlay that we developed. So ultimately, we really took the best of some of the existing CDN, I want to say approaches, the best of some of the programmatic work that was done with SD-WAN, added to it, and created the Teridion Global Cloud Network. And this Elad, covered in great detail as well. If you want some of these slides, we can get them over to you. I am going to skip through this briefly. A little bit on system topology, and Bill will cover this in additional detail, but we talked about the cloud operators, cloud service providers, the virtual routers, the Teridion cloud virtual routers that exist in the cloud service providers, the Teridion measurement agents, and then the tunnels that we create on demand between the TCRs. And as Elad mentioned, this can scale on a global level. It scales linearly based on the customer traffic, and it changes based on how the underlying internet congestion topology changes. So looking at our footprint, this changes day by day. These are the different cloud service providers that we were in about 2 weeks ago. But this abstraction layer that we've built that allows the TMS to talk to AliCloud or talk to NTT or talk to Selectel in Russia, all of them speak their own languages in terms of how you provision CPUs and cores and storage and disk and everything like that. So this abstraction layer actually understands what it needs to call for each and every of these cloud service providers. And if we decide we need to change a path from global cloud to soft layer, it understands the different ends of that path and what I need to call up on demand. And we have some paths, for example, one customer, Quixi, origin, a TCR in India would be a NetMagic. I think it was hopping through Google Cloud in Tokyo and ended in soft layer in the United States. So a single path, a single VBN can actually span n number of cloud service providers, which is actually pretty unique. This is the beginning of a simulation that we have, or I should say really a live view of the Teridion measurement agents. And this gives you an idea of where they'd be deployed across the world. This was actually a live view taken from the TMA about two weeks ago. The orange dots are the various cloud data centers, this in case North America. And we're actually showing the calculated latency to different points in the globe where you would imagine, red is longer latency than yellow than green. And over the next number of months, we're actually going to make this publicly available where you're actually going to see what's happening with our measurements in real time and then what's happening with our virtual backbone networks in real time.
Now, are these measurement points separate from the virtual routers? Are they too?
So as Elad said, I like the term pioneer because before we actually spin up Teridion Cloud Virtual Routers, the TMS, the Teridion Management System will go ahead and spin up the Teridion measurement agents, but the virtual routers also have measurement agents built in. So where we have these thousands of live virtual routers, we're actually conducting that measurement as well.
So you've got fixed measurement points, and then in addition, you have the dynamically spun up virtual routers that are also doing
measurements.
And he mentioned that it was kind of like a sonar for the internet. Can
Yes.
you give any more technical description of how they're polling the health of the entire internet?
Can we cover that in the Q&A if we have a time at the end of the session? Okay, thank you. This is really a quick look ahead into what Bill's going to present as far as provisioning, but as you heard earlier, it's a very simple CNAME change. It's really transparent to the end user. In fact, there's very little that our direct customer, like a Box or Ignite, actually has to do. One thing's very important about this, and in fact, there was a meetup we did a couple days ago where this was presented by NS1. We partner with NS1 and we partner with Dyn to provide the managed DNS, the dynamic DNS, GeoDNS, everything like that allows us to make the CNAME changes. And this slide's actually very telling because of two things. One, there are services like this that are offered from Amazon, but in that case, you're going to be using their Route 53, and it's not as effective in providing this real-time change capability across the global internet. Obviously, DNS isn't their core competency there. And same thing with Akamai. If you're using an Akamai service, you're using the Akamai DNS, it isn't their core competency, so you're not going to have as good performance. So because we're call it independent, we're allowed to really take the best of the technologies, the best that's out there in the market, and apply it across our global cloud network. Last but not least, just a couple performance slides that Elad hinted to. This was a file sharing synchronization company, 5 meg file download across different parts of the world. Bill will go into some details on exactly how we use Catchpoint. We'll show you some live demos. Teridion, obviously, in the teal, non-Teridion in the dark red. This was very interesting in that we were working with a EFSS company. Before they deployed Teridion, some of the worst performance out there in the internet compared to some of the competitors. And then with Teridion, by far and away the best performance out there across the global internet. And then Elad also mentioned the ad serving company we're working with, where before Teridion, and this is very important when you're in a mobile device and you're bringing up these live ad card feeds, and if you have a timeout or if things just don't happen in time, the user's going to turn away, it's not going to be effective, you're going to lose revenue. They have a very predictable, low latency response now, even between Silicon Valley endpoints in India, and they're serving their end customer base that much more effectively. So last but not least, we talked about the evolution of networking. So we see ourselves playing a fundamental role here where, legacy networking, end users in the corporate environment to the corporate data center. Then you began to see a transition where you introduce hybrid clouds. You had, public cloud operators with some of the workloads transitioning. And this is where you introduce MPLS, WAN optimization, SD-WAN. But we see an essential next step in this evolution where instead of just going over the traditional internet, since your data centers, your workloads, your applications are all in the cloud, you're delivered from the cloud, move to a cloud overlay as soon as you can, and you will get better performance.